we'll discuss about the topic that is the differentiability. What is differentiability? That means a function fx is said to be derivable or differentiable at the point x is equal to c if Lhd is equal to Rhd, where Lhd is equal to left hand limit derivative that is equal to f dash c minus that is equal to limit fc plus h c minus h minus fc divided by minus h, and Rhd is equal to right hand derivative that is equal to f dash c plus that is equal to limit fc plus h minus f divided by h tends to 0. This is Lhd that is left hand derivative, and Rhd that is equal to right hand derivative. Then this formula comes in which way? How can you say that the Lhd is this and Rhd is this? We have to understood about the definition. So if the function is differentiable, at the point also another is interval is given. So if at the point is given, then Lhd is equal to Rhd. It must Lhd is equal to Rhd, where Lhd is left hand derivative and Rhd is right hand derivative. So then how will it comes? Now comes to the proving technique. Let you take a function. This is a function. The function is in this way. Cba point, suppose Cba point. This is fc. The distance is fc because y is equal to fx. Be a card here. So small change that is equal to c minus h. That means the function is c minus h here. Then this is what that is c plus h. So this is c plus h. The distance is c plus h. This is angle. This angle is theta 1 angle. This angle is that is theta 2 angle. This is theta 2 angle, and this distance is equal to. So this point is here f c minus h. This point is here fc, and this point is here fc plus h. So that's what the difference is here. The point is that fc here fc plus h minus fc. Here this distance is equal to h. So that's why this distance is equal to h. This distance is equal to h. So that's why this distance is equal to h. So the slope that is equal to tan theta 1, which is equal to that is equal to fc plus h minus fc divided by h, that is perpendicular by base. So here h tends to 0, means h is nearer to 0. H is nearer to 0. That means here, that 0 here, that is equal to 1. That it is nearer to 0. It may h may be 0.001, h may be 0.00001, whatever. So that's why we have to take limit h tends to 0. That is actually called here f dash c minus, which is equal c plus, which is equal to, that is equal to rhd, that is equal to limit h tends to 0 fc plus h minus fc divided by h. Why it is rhd? Means this point say right side. So that's why the right side derivative is here. Similarly, this is what? Tan theta 1. Similarly, in left side is there what? That is equal to tan theta 2. So tan theta 2, that is equal to this distance is this distance. So this distance is equal to what? This distance is equal to fc minus fc minus h divided by h. So here limit h tends to 0. So that's why this f dash c minus, that means left side derivative. So that is Lhd is equal to limit h tends to 0. Here fc minus fc minus h by h. You can say that is equal to limit h tends to 0 fc minus h minus fc divided by minus h, which is equal to tan theta 2. This is the derivation that Lhd and Rhd. How Lhd and Rhd come? So that is the definition. If Lhd is equal to Rhd, then the function, this function is differentiable. This is what? It is a simple curve, which is not discontinuous. This if that the function is suddenly grew and suddenly changes the position. That time we cannot say that is differentiable. But here smooth curve is there. So that's why it is differentiable. So that the technique is there. Lhd is equal to Rhd. That's why the function is differentiable at the particular point. That point is here. C point is at a particular point. So here tangent is unique. Here tangent is unique. If the curve looks like this, suppose this suddenly break this. That means here tangent is infinite, tangent will come. Tangent will come infinite. So that's why we cannot say this is a differentiable point. Then comes to the differentiability on the interval. This is on the point and in the interval. If the interval is open, differentiability at interval means एक open interval में, एक close interval में. A function fx is differentiable in open interval AB, then fx is differentiable or derivable for all point with interval. Means on that time we have to find out. So simple Lhd and Rhd, and if the Lhd equal to Rhd are finite, then that time say that the function is differentiable. Here this is a function y is equal to fx function. If the point is here C, in between A and B, that is x is belongs to A and B. So C be a point here, x is C. So which is belongs to A and B. So A and B के अंदर में open interval का अंदर वो है. So इसीलिए वो लेफ्ट हैंड डेरिवेटिव निकालना है, राइट हैंड डेरिवेटिव निकालना है. If left hand derivative equal to right hand derivative, which is equal to finite. If it is infinite, we cannot say that is a differentiable. If it is a finite, then we can say this is a differentiable. This is a here on open interval. If closed interval is given, then what we will do? Here, close interval is given. If a close interval given, a function fx is differentiable in a closed interval AB, then fx must be differentiable in open interval AB, and fx is differentiable at the end point of A and B. Means right hand derivative at the left end of a point x is equal to, that is f dash a plus, and the left hand derivative at the right hand point x is equal to b, that is f dash b minus. Means here, that is if you take the graph, that what the graph say, this is a curve, this is equal to a, this point is b, here a is less than x, or here c point is less than here b, means this is a c point, this is y is equal to fx. Here f dash a plus means that is equal to limit f a plus h minus f a by h. Similarly, f dash b minus, that is equal to limit f b minus h minus f b divided by minus h tends to 0. That means here, these two are finite, it must be finite. Here, f dash a plus and f dash b minus must be finite. If it is finite, then the function fx is differentiable in the closed interval. It must be finite. So then we can say the function is differentiable in closed interval. If it is not finite, suppose anyone is infinite, then we cannot say that is equal to differentiable in closed interval AB. This is here important thing. If a function f is differentiable at x is equal to c, then it is continuous at that given point. Suppose that x is equal to c point, and but converse is not necessarily true. So that proof, let a function fx is differentiable at x is equal to c. That means limit fc plus h minus fc by h tends to 0 is exists, and which is equal to f dash c. Now fc plus h minus fc divided by h, you can what, you can multiply both sides, okay, divide. Here you can see that can do also. Here f dash c is equal to limit fc plus h minus fc by h when h tends to 0. That means you can write now fc plus h minus fc, that is equal to fc plus h minus fc divided by h into h, we can write. Similarly, that means here that is equal to taking limit h tends to 0 both sides, fc plus h minus fc is equal to limit h tends to 0, here fc plus h minus fc by h into h. So that value comes limit h tends to 0, fc plus h minus limit h tends to 0 fc, which is equal to this value comes f dash c, this value h. Why it is f dash c? This value is here. F dash c is equal to limit h tends to 0 fc plus h minus fc by h. So that's why this value it comes to f dash c into h. So now here that limit h tends to 0 fc plus h minus fc is equal to 0. Why it is 0? If it is h tends to 0, that value comes 0 here. Then limit h tends to 0 fc plus h is equal to fc comes. That according to the definition, that value if equal to fc, then the limit exists, a limit continuous. That means function fx is continuous at x is equal to c. That here, if the function is differentiable, then the function fx is continuous also. Converse is not true. How? You have to take any counter example also. That you take that counter example fx is equal to modulus of. Let you take counter, but as it is not true. Example, fx is that is equal to modulus of x is continuous at x is equal to 0, but f is not differentiable at x is equal to 0. First you have to prove LHL is equal to limit x tends to 0 minus f of x, that is equal to limit x tends to 0 minus modulus of x. That means limit h tends to 0, 0 minus h, which value comes limit h tends to 0, h, that is 0. Similarly, RHL means right hand limit, that is limit x tends to 0 plus of f of x, that is equal to limit x tends to 0 plus here modulus of x, that value comes limit 0 plus h, h here change to 0. That means limit h tends to 0 h, that value comes to 0. Here f of x, that is what? X tends to 0 if you put, that is mod of x, x tends to 0, that is 0 comes, which is equal to f of 0. Now LHL is equal to RHL is equal to functional value f of 0 is equal to 0. So f is continuous at x is equal to 0. Here f is now continuous. It is not differentiable. Now you have to check, that is LHD is not equal to RHD. Then LHD according to the formula you have to find out, and RHD according to the formula you have to find out. Here function that fx is equal to mod x, here x is equal to 0. So LHD that is equal to f dash 0 minus, that is equal to limit h tends to 0 f 0 minus h minus f 0 by minus h. That value limit h tends to 0, that is 0 minus h का modulus minus 0 का modulus divided by minus h, that is limit h tends to 0 h by minus h, which is equal to limit h tends to minus 1, the value comes minus 1. Now RHD is equal to limit h tends to 0, this is मतलब here f dash 0 plus that is equal to limit f 0 plus h minus f of 0 by h. Here h tends to 0. That means limit h tends to 0. Here 0 plus h का modulus minus 0 का modulus divided by h. That is equal to limit h tends to 0, h by h, it comes to 1. Here, LHD is not equal to RSD. LHD is not equal to RSD. So, F is not differentiable at x is equal to 0. That means here every function, differentiable function is continuous, but every differentiable function is not continuous. Every continuous function is not differentiable. That means converse is not true. Similarly, you can prove also by using graph technology. Means here this is a modulus function ka graph. X-axis, this is y-axis, this is 0. This is equal to y is equal to x. Here y is equal to minus x. Here right hand derivative that is equal to 1 and the left hand derivative that is equal to 1. Here right hand derivative is not equal to left hand derivative. So that is a okay. That's why that function is not differentiable. So sometimes that a different technique also they are for shortcut technique. Different large number of questions also come in Iit-Jee and different entrance examination. That time we cannot solve any simple basic funda method. So that time other technique we have to apply. That shortcut technique से हम करने से जल्दी कर सकते हैं, नहीं तो बड़ा बड़ा लार्ज हो जाएगा, तो इसीलिए वो कॉम्प्लिकेटेड ज्यादा बन जाएगा. तो शॉर्टकट टेक्निक फॉलो करेंगे